This video represents the culmination of everything we've learned in logic so far. So we're going to look at arguments, and we're going to determine if the argument is valid or invalid. And here's how we do that. So you'll be given these arguments written this way that says not P, if not P, then Q. And then we have this not Q, and then we have a line, and we have these three dots. The three dots mean therefore, and therefore not P. So is the symbolic argument valid or invalid? So I've rewritten this argument here in terms of symbols here. So we say not, if not P, then Q. And when you write the second line, you put an and not Q, therefore, or then, not P. So to solve this and to find out if this is valid or not, you need to create a truth table. So let me set up my truth table. So recall, we set up our P values. We have two truths and two falses, and then we alternate true and false with Q. So the first thing we need to find out is this internal, inside these parentheses here, let's find out what not P is. So if we make a list for not P, then we change the truth values of P from true, true, false, false to false, false, true, true. Now we need to do an if-then statement. If not P, then Q. Now let's recall, I'll pull up the table here, but you should hopefully start to have this in your memory bank by now. Remember that the conditional statement is true all the time unless the first part is true and the second part is false. So again, right here, conditional is false only when P is true and Q is false, when the first part is true and the second part is false. So we're looking for not P to be true, and we're looking for Q to be false, and you see that occurs right here. That means that one is false and all of these are true. And my heading for that row is not P, then Q. Now our next thing we need after that, we're going to do a conjunction, and we're going to do not Q. So let's make a list of not Q. So again, to do not Q, you alternate the truth values to be the opposite of what they were for Q. So false, true, false, true. And now we're going to do a conjunction between this column here that we just wrote, right, for that conditional, and not Q. So recall, for a conjunction, it's true only when both P and Q are true. So right here, they're both true. So this line will be true, and the other lines will be false. And so my heading for that one will be everything on the left side of my original conditional statement. And then the very final part is we have a conditional of all of those things that we just wrote, and we have not P. So we already have not P. So we're going to compare this one first, and we're going to compare it against not P. And again, it is a conditional, so we're looking for when P is true and Q is false. So when is this true and when is this false? All right, so you see we have a true here and not P is false right there. So my very final statement is going to have a false on that line. And the rest of it, since the leading statement is false, the antecedent is false, recall that that means that everything else is true. So we have true, false, true, true for that final statement. I won't write that heading because it's just all that stuff. So as we look at our final column here, if the argument is valid, everything is true here. But you see right there, we have that one false. And that allows us to come over here and say that this argument is invalid. Okay, so that's an example of just using symbols about how you do this. Now we're going to come down and do this one where we use words. Okay, so here's our example, and just FYI, these are other different examples, not this example, but different examples that show how to do a truth table for word statements, if you want to watch another one after this one. So it says you painted the room with red, or it looks bad. Recall we say and, now it looks bad. Therefore, today you did not paint the room with red. So let's write out our statements P and Q. So let's make P is you painted the room with red, and Q will say is it looks bad. So our first line, we will write that as you painted the room with red, that's P. Or, so or is the disjunction, it looks bad, P or Q. All right, so we put that in parentheses, that's the first line. And recall the second line, we put an and, now it looks bad. So we'll say Q. And for all of that, we're going to say, therefore, our conditional statement, you did not paint the room with red. Therefore, you did not paint the room with red means not P. So we're going to build a truth table now for these values of P and Q. So as always, we're going to start just like we did above with our P's and Q's, where P is true, true, false, false, and Q is true, false, true, false. And now we're going to say P or Q. Our first thing we need to find is what's in parentheses, P or Q. So recall for a disjunction. I'm going to not scroll back up, I'm hoping you know, but you can look at it if you have it written down somewhere. This is true everywhere unless it's false, false, and then it's false. So this is going to be true, 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 false. All right, now we need to do that, and we need to do and Q. So P or Q and Q. So we're going to do a conjunction of these two columns here. So recall, a conjunction is only true when both things are true. So true, true is true, and we also have a true, true here. And so false, true, and false, false are both false. And now our final piece is to do a conjunction of that with not P. So let's go get a row of not P here, a column of not P. So we'll alternate our truth values on P. And now we're going to do this final conditional here. So recall again, for conditional, if the first part is true and the second part is false, then we have a false statement. So right here, if you look at this first row, everything on the left is true, and then not P is false. So we would say true, false means that is false. And if you check the rest of them, true, true is true, false, false is true, and false, true is true. So we're going to write true, true, true. So now we have to come over here and say either A, the argument is invalid, or B, the argument is valid. So here we say the argument is invalid, and then in symbolic form the argument is, and in that box you will type in this statement right here. That's all you have to do for that part of that question, is to type these symbols in to represent the statement. Because as they say here, P represents you painted the room with red, and Q is it looks bad.